Hello, my name is Anita and I am the maths exams expert. So in this lesson, we're going to look at completing the square to find the turning points of quadratic graphs. So the reason this is such a big lesson is that we're going to learn how to complete the square, but we're going to use that skill and link it with lots of other different parts of the course. So you can see here, the first thing we're going to do is get an overview of the different types of functions, which isn't strictly speaking completing the square, but we're going to tie the whole lot together. We're then going to look at how to actually complete the square. We're going to see how we can use the completed square form to find the maximum or the minimum turning point of a quadratic graph. And then we're going to look at applying the technique, which is where your exam practice comes in. And those questions will be similar to the type of questions you would see in an exam situation. Right, so first thing we're going to look at is types of functions. So throughout your studies in maths, you are going to be dealing with lots of different types of functions. So the first one is the linear function. This here is your straight line graph. So there's your linear function. It goes up in a straight line. You'll see the algebra of it. You have got examples are x plus 2 and y is equal to 3x plus 4. You'll notice that there are no powers of x greater than 1. Okay, so there's no squares, no cubes, nothing like that. So when your algebra is linear, it's going to have just powers of 1, and the graph is going to look like a straight line. The graph might slope upwards or it might slope downwards, having a positive slope or a positive gradient, or a negative slope or a negative gradient. Okay. Here we've got a constant function. Now, if you look at this function here, this line goes through 1, 2, 3. It goes through the y coordinate of 3, which means every single point on this line has a y coordinate of 3. 1, 3, 2, 3, 3, 3, 4, 3. So its equation is y is equal to 3. So those are constant functions. If we had a function that went like, let's say this is going to the x-axis at 1, 2, 3, 4. So the equation of this would be x is equal to 4. Right. What we've got here is an absolute value function. Now, we'll see more of these in Algebra 3, but we're just going to mention it for now. You'll notice we've got these modulus bars, or absolute value. Whatever is inside those modulus bars, we're forcing it to be positive. We're taking its absolute value. And so this modulus function, you'll notice it's existing up here in the positive region of the graph. So everything, all the y values are going to be the positive version of whatever the x value is. I'm not getting into it for now because we'll see it in Algebra 3. For now, I just want you to be familiar with it. You get these kind of pointy V-shaped graphs a lot with these. A logarithmic function and exponential functions, again, these are for Algebra 3. So a logarithmic function has an ln or maybe a log in it, and you'll see it doesn't touch the y-axis there. This particular one, y is equal to ln of x. It has a gradually increasing shape. The exponential function then has got the x, the variable, is a power. You've got the number e here. E is the number 2.718. Please don't worry about memorizing all of this now if you have never learned it before. I'm simply bringing them all together in one place, making you aware of them, and we will cover all of these logarithmic and exponential and modulus functions in Algebra 3. So don't panic, but we want them all in one place so that when you come back to revise, you'll have everything together. So in these exponential functions, as we said, the power is x, and these exponential functions grow very rapidly, unlike the logarithmic function, which grows slowly. So exponential graphs are used a lot to model the growth of bacteria, the spread of disease, and so on. You would have heard the words exponential growth a lot, maybe around the time of the COVID pandemic. So let's have a little look at this one then. This is called a reciprocal function. Now, a reciprocal function has got the x on the bottom of a fraction, the x as a denominator. You'll notice it doesn't exist here, and it doesn't exist here. It has what we call asymptotes in those places. That line should be on the x-axis. It has asymptotes. So what's going on there is that the line, the curve, will get closer and closer and closer to the x-axis, but never actually touch it. And it'll get closer and closer and closer to the y-axis, but never actually touch it. You might see x is not equal to 0, and that means x cannot be 0 because you simply cannot divide by 0. Can't be done. Try it in your calculator. It'll tell you it's a math error. Next one here. There's this word here, goniometric function. Now, that's not a word that I would be familiar with. It's not a word that I've heard in use. The word that I would use for this kind of a wavy function is a sinusoidal function. It usually has a cos or a sine in it. Moving on then to quadratic functions. Quadratic functions are ones that you are possibly familiar with by now. A quadratic function is a U shape or it's an N shape. I know we met these types of functions before when we were solving quadratic graphs. A quadratic function has got an x squared term. It might have x's in it as well, but it definitely has an x squared. And then you've got cubing. I would say that's cubic, right? A cubic function. So cubic function, if we've got y is equal to x cubed, so the cubic function does a little wobble. It goes up, bit of a wobble, and up again. That's for this first one here, looks like that. If you had an x cubed, all of these have x cubed term. If you had a cubic that had maybe a square term and an x term, it might look something more like this, more like a roller coaster. That's our 9 basic functions covered. Let's zoom in now to the one that we're most interested today, and that is a quadratic function. We said a quadratic function is a U shape or an N shape. If it's a U shape, the coefficient of x squared is positive. The number in front of x squared is positive. If it's an N shape, the coefficient of x squared is negative. So it might be, for example, y is equal to minus x squared, I don't know, plus 3x plus 2 would be a sad face, an N-shaped curve, because the coefficient of x squared is negative. So a U-shaped quadratic is going to have a minimum turning point, and an N-shaped quadratic is going to have a maximum turning point. It's never going to have a maximum and a minimum, because where a cubic can do an up, down, up, a quadratic only ever does one turn, like that or like that.